Question 19. Find the equation of the tangent of the line tangent to the function at the given point. Basically, what they want us to find is the y equals mx plus b. Okay, they want us to find the equation of the tangent line. Okay, now how would we find this? How would we identify y m as slope, also known as derivative? And how would we find b? Okay, so let's just first write the equation here in the corner. So y equals mx plus b. Okay, first step would be finding the derivative of the function. Why? It's because we said that the derivative is also it means the slope, but we use derivative in calculus, we say slope in algebra. So m here, m is known as slope, okay? Or we can actually call it derivative in this case. Okay, so finding the derivative of this function will give us m, which will be the first step of solving this question. So if we find the derivative of this function, it would be 3, we'll use the power rule. So 3 goes down, it becomes 3 power x, then minus 1 from the power, it becomes x squared. Now let us substitute for the value of x, because they gave us that x equals negative 1. So it becomes 3 times negative 1 squared, and negative 1 squared is basically 1, so the negative will go, and 3 times 1 is 3. So this is m equals 3, m equals 3, okay? And if we go, oops, wait, my bad. So let's write it here, y equals 3x plus b, okay? Now let's first find y in order to find b, okay? So in order to find y, we will just substitute for the value of x right away. So negative 1 cubed will still be negative 1. Since it's an odd power, then the sign will not change. So it will become negative 1 equal 3x plus b. Now, what is x? They already told us that x is negative 1. So let's write here negative 1 equals 3 times negative 1 plus b. So it becomes negative 3. And now in order to find b, we will put 3 or negative 3 to the other side. So it becomes negative 1 plus 3 equals b. So b is equal to 2. Now let's write the equation. So it becomes y equals m, which we said is 3, so 3x. And b we said is 2, so plus 2. So this is the answer for the first question. Moving to the second question, we'll do the same thing. In order to find m, we will find the derivative of the function, which is x squared. Then we will substitute for the value of x right away to find y, and we will put x in the side of y in order to find b, and then write the equation. These are the steps to find the equation of the tangent line. Okay, so let's find m, the slope, the derivative. So put 2 down, so it becomes 2x, then minus 1 for the power, it becomes x power 1, which we don't have to write. Then substitute for the value of x, so it becomes 2 times negative 2, which is equal to negative 4. So m equals negative 4. Let's write the equation again here. Actually, okay, no, we don't have to delete it. So let's write here y equals negative 4x plus b. Now let's find y. Let's substitute for the value of x right away. So x, which we said is negative 2, squared will equal to 4. So 4 equals negative 4x plus b. Now let's substitute for the value of x. They said that x is negative 2. So it becomes here 4 equals negative 4 times negative 2 plus b. So negative 4 times negative 2 is positive 8. And let's put 8 to the other side, so it will give us negative 4 equals b. Now let's finally put the values of b and m in the equation. It becomes y equals, I believe, what is x? We said that it will be negative, wait, no. The slope will be 2 times, yeah, negative 4. Okay, so it will be negative 4x, and b is minus 4 too. So that's the answer of question 19, A and B. Okay. Moving to question 20. The position of a particle moving along the x-axis is given by s, or S of t equals 5t squared plus 2. Find the velocity and find the acceleration. So, in order to find these two, how do we find velocity and acceleration? Like we learned these things in physics. Why do we have them in our math exam? Basically, the idea behind this question is that I think it's speed. So the derivative of speed, the single derivative of speed will be the velocity, and the double derivative of speed will be acceleration. I'm not sure if it's speed actually or something else, but it doesn't matter what it is. Velocity represents the single derivative of this function, and the acceleration represents the double derivative of this function. Okay, so they want us to find f of f prime x and f double or yeah f double derivative of x. Okay, so x equal here. So what is the derivative of this function? Basically, put 2 down. So and then minus 1 from the power. It becomes 5 times 2 t, and then 2 minus 1 will be 1, so we don't have to write the power. Plus 2 is a constant, so it will be 0. So 5 times 2 will be 10t, and then plus 0, we don't have to write it, so it will be 10t. And the derivative of this, in order to find the double derivative, or aka known as the acceleration in this question, will be just 10, because the derivative of any variable will be 1, and 1 times 10 is 10. Moving to question 21, sketch the graph of f derivative of x on the same graph. Now, first step will be, let's pick the purple color. Okay, so let's go from the stomach of both of the functions. So here, this is the first one, and this is the second one. Okay, now let's look at the behavior of the graph from the left hand side. Okay, from the left hand side, we see that the tangent lines are increasing, so it's positive. Okay, hence our answer, or we should first sketch from the right hand side of this function. It will be going like this. Well, before we actually solve it, let's first identify what is this function. What is the function of f(x)? It's actually a cubic function, because here it crosses the x-axis 3 times. So this is the first time it crosses it, this is the second time it crosses it, and this is the third time it crosses it. Okay, and if we take the derivative, then it will be x squared, a parabola. Hence it should look like this. Okay, but now, okay, let's just draw it here as a point of reference. Now, from the left hand side of this graph, we see that the function is actually decreasing. Okay, so it should go down like this. Okay, like this. Now let's go here. So from the right hand side, it's decreasing, so let's just connect these 2 points, and from the left hand side it's actually increasing. So let's just put it up like this, and now let's just make the drawing better. So it should look like this. Is it sketch? Yeah, sketch. So it doesn't have to look like super accurate, just get the shape right like this. Yeah, this is better. Moving to the last question. So at one of the label points of the graph, both dy over dx and d squared y over dx squared are positive and negative. First of all, what is dy over dx? What is d squared y over dx squared? Okay, don't be scared by this. This is just basically another way or another form of saying double derivative. Okay, and this is another way of saying just the single derivative. Okay, so basically they want the point or 2 points in which the first or single and second derivative are both positive, and a point in which the single and double derivative are both negative. Okay, so let's first look at point A. We see that point A, the single derivative or the tangent line, is decreasing, so it's negative, but it's in a point where the concavity is up, so it's positive for the double derivative. So A is out. When we look at B, we see that the tangent line or the single derivative is increasing, so it's positive, and it's also concaving up, so positive. So B is actually the first answer for the positive sign of dy over dx and d squared y over dx squared. So B will be positive, therefore B, or just right here, therefore B is positive for both f double derivative and single derivative and double derivative. And then if we go to C, so we see that the single derivative is increasing, but the double derivative it's concaving down, it's negative, so C is out. Okay, when we look at D, the single derivative is 0. We see it's at a horizontal line, it's at a point, I forgot what was the point called, but it's basically the point in which the graph changes from being a positive tangent to a negative tangent, and it is represented by a horizontal line. So D is 0 for single derivative and negative for double derivative. It's concaving down for double derivative. So D is also out. But when we look at E, we see that it's still concaving down and the tangent line is negative. So it's negative for single derivative and negative for concavity or double derivative. Hence, E is our answer. Therefore, E is negative for both f of single derivative and this double derivative of them. And I believe this concludes, yeah, this is the last question. Thank you so much for watching the videos. And if you need any additional help, there are also other videos where I explain the skills needed if you found any trouble with me solving the steps themselves. And if any of the questions don't make any sense, then I'm here to help. It's okay.